Okay, welcome back. And let's look at the first official module of the training course. This is the first of 9 modules, and we're going to be looking at the background of Revit and a general introduction to what to expect from the Revit software, what it is used for, and who it is used by. So Revit is really a 3D parametric modeling environment. The outputs of Revit is drawing production. So as opposed to using a system such as AutoCAD, which is more CAD and line based and 2D based, although AutoCAD does have some very powerful 3D modeling features, it's generally used as a 2D drawing production environment, whereas Revit provides a 3D parametric modeling environment that produces models, information, and also by extension, drawings. So Revit is pretty much the leading BIM or building information modeling software package and recognized across the world as pretty much the industry standards by architects, engineers, and constructors. So what is parametric modeling? Parametric modeling refers to the elements in the model having the ability to maintain a relationship between themselves and objects around them. I'll show you a quick example of what that means, and I'll jump back into the model that we created in our test drive tutorial. So just by accessing a view here, I'm going to move a component. I'm going to select this wall and I'm going to click and drag it and I'm going to move it to a new location. Immediately you can see that the other entities, the connected walls that connects to it, moves along with that wall. More than that, we can actually move elements to things such as grids, and we can snap them to grids and lock those positions, which means that when I move the grid line, that wall is going to move along with it. That is what we mean by parametric. In addition to this, whenever I move something in a specific view, such as my plan view here, it'll also move in the 3D view. As we can see here, we've moved that wall. It's still selected. Notice that. I've also got it selected in this view. It will move in section views, it will move in details, it will move in schedules and quantities that I have produced. It'll update those and recalculate those, meaning that beyond the 3D visual geometrical elements is also got information attached to it. So this element is not just volumetric and a dumb entity. It's actually intelligent and it's built up of components that replicate or represent real live elements or real world elements. So there is intelligence attached to this. And this is really what building information modeling is about. So of course, Revit is not BIM. Excuse me, Revit is not BIM. BIM is a methodology and a workflow and a concept and a way of doing things, a project management concept really. Revit is a BIM compliant tool, meaning that it fits really well within the BIM environment and the BIM space. But Revit on its own is not BIM. But Revit is not just a 3D modeling package. Again, it's got that information component attached to it that is really well aligned with the I in BIM, which is information. So when we look at information, then we start to work with intelligent objects. And that covers the next point here, intelligent components, which I just mentioned. Now, it is not just used for architectural components. In the modules in this course, since it's a level 1 course, we'll be focusing on basic elements such as walls, floors, stairs, roofs, windows, doors, furniture, foundations, etc. But we don't get into the complicated components such as structural steel connections or structural trusses or structural framing or anything like that. But those components are all part of this ecosystem, including the systems families, which would include HVAC, mechanical components for ventilation and ducting, plumbing and piping, electrical fixtures, etc. So it goes beyond just walls, floors, and doors. Revit uses a system called families, which is pretty much a grouping of objects. So imagine in AutoCAD where you can set up blocks and dynamic blocks of components. And although they are 2D in Revit, you can consider families to be the same thing. It is a library of components that we can load into the project. And of course, they have a lot more intelligence attached to them than simple 2D blocks or dynamic blocks even. So in Revit, when we talk about families, it is split up into different categories. So we've got system families, such as walls and floors, and then we've got component families or loadable families such as doors and windows. And I'll just show you an example. If I selected a door family here and placed that in the model, let's just plonk it over there, then you'll see it's created this component. This was a loadable family, meaning that it's got parameters that drives the geometry of this element. A system family, on the other hand, such as a wall or a floor, is a higher level component or a family. It means that you cannot really create a single entity of a wall. A wall is defined by a start and an endpoint and a base level and a top level and potentially attached to something such as a roof or a floor, right? Whereas a wall is a freestanding element. Yes, it's hosted by a component such as a wall. A door that normally wouldn't just stand on its own. It would be hosted by a wall, but it is something that can have multiple different types of geometries or sizes associated with it. We're going to be looking at that into a bit more detail later on as we go through this course. But I'd like to show you one more example. And what I'll do is I'm going to just place a component here, and I'm going to load a family from my library of families here in Revit. Now, in order to be able to access this, I need to have the correct libraries installed, and I'm going to cover that in the next module. For now, I just want to show you what it looks like if we start loading families into the model. And I'm going to select furniture and appliances, and let's just go to furniture and fittings, and I'm just going to select this one that says double bed. Okay, just as an example. And I'm going to place this anywhere in the model. Now, this is not a main building component or a structural or an architectural feature as such, but it is something that we would like to visualize and load into the project. This could be located anywhere. It is not hosted by a host element. And it is a freestanding component, if you will. So this is considered a loadable family and a good example of a loadable family. When we talk about system families again, those will be components such as walls, floors, and other objects that I'll cover, like roofs, as we go, and stairs as we go through the module. All right, now let's just jump back to the background. Constraints and relationships. So we saw that we can attach elements to other elements, such as walls connecting to grid lines. And when we move those grid lines and we've created that relationship, then the associated entities will move along with them. Um, the parametric nature of Revit allows for quick design iteration. So yes, we can set up multiple design options and changes, and a change anywhere is a change everywhere in Revit, meaning that we cut out that manual labor part of updating drawings as we would traditionally using a CAD system, where if we made a change in a layout view, we would have to go and update sections, elevations, details, and so forth. Not in Revit. In Revit, this is all managed automatically. And of course, as we've mentioned before, it is a data-rich environment. So apart from the geometry, there is information attached to those elements. It also allows for interdisciplinary coordination, meaning that in more complex model setups and project setups, we have something called work sets and work sharing within Revit, where we can collaborate together on projects or work collaboratively on projects across multiple disciplines. That's not something we cover in this level of the course. We'll cover that in level 2, but just be aware that those environments do exist. And then just to give you some more background information. So what is Revit used for? According to Google, and I guess the general consensus, Revit is a software product and comprehensive workflow from Autodesk that helps architects, designers, builders, and construction professionals work together, as I've mentioned before. The software is a sophisticated way to create models of real-world buildings and structures. It is primarily used in BIM or building information modeling. Same thing. All right. How long does it take to learn Revit? It depends on what you really want to learn and how much effort you put into it and what background experience you already have. But around 3 days to get comfortable, I would say, on a basic level. 3 weeks to get comfortable with basic modeling, and around 3 months to get fairly competent with the common tools used in everyday office environment. That could vary depending on the effort that you put in, the experience that you might already have, and the environment that you find yourself in. Why is it called Revit? Revit is actually a term used for revise instantly. So the fact that you can make a change anywhere and it updates everywhere is what the name is based on. So that revise instantly became Revit, right? Revise it. Is Revit better than AutoCAD? Is a question that I hear a lot, and I often hear people saying like AutoCAD, is so old and outdated, and Revit is so much better. They're two different things. You can't compare them. AutoCAD is a CAD-based platform. Revit is a BIM compliant software. So I don't think they should be compared either. AutoCAD has got really strong modeling and drafting capabilities. And AutoCAD is a very powerful and essential piece of software that I think should not be discounted in the architecture, engineering, and construction industries. However, I feel that Revit has got a really strong footprint and is a really effective tool when it comes to architectural and structural and mechanical and engineering and plumbing, or MEP, model development. But when you start to get to more complex modeling in other disciplines such as civil and earthworks, road design, complex bridges, then I feel that Revit is not the perfect tool for that, and other tools such as AutoCAD Civil 3D or perhaps Open Roads or whatever it may be would be more tailored and more equipped to deal with those kinds of disciplines. So yes, Revit is amazing. It's extremely powerful and it's an essential piece of software in the industry, but I wouldn't compare that to AutoCAD or Civil 3D or other CAD platforms. Not that Civil 3D is a CAD platform. Civil 3D is considered to be a BIM compliant equivalent of Revit, but it's built on top of the AutoCAD platform. Okay, enough of that. Let's look at the Revit model element types. So I briefly started to talk about system families and loadable families and such, but let's look at a breakdown of the three types of elements in Revit projects. And they are model elements, datum elements, and view specific elements. Model elements represent the 3D geometry of stuff. So anything that you can see as a 3D object in the Revit model is a model element. Datum elements, on the other hand, are things like levels, grids, elevation views, etc. So a grid is a datum element. If we go in here and we look at the levels, that is a datum element, right? And then we've got view-specific elements. These display only in the views in which they are placed. They help to describe your document, describe or document the model, for example's dimensions or view-specific elements. So these would be annotations. So whenever we create an annotation object, such as this one, and I'll just create a quick dimension between these grid lines here and place it there, these would be those components that we talk about, the view-specific elements. Okay. Here is a bit of a breakdown of these elements. So we can see from all of the Revit elements, we've got the three categories: model elements, datum elements, view-specific elements. Under model elements, we've got hosted elements and we've got model components. Okay, so hosts, not hosted, apologies, hosts, and model components. All right, hosts or host elements are generally built in place at the construction site. And examples of that would be walls, ceilings, structural walls, roofs, stairs, etc. So those will be your system families. Okay, and then we've got model components such as windows, doors, furniture, beams, structural columns, things like that. So those will be your model components. Then, as we mentioned, under datum elements, we've got grids, levels, and reference planes. View-specific elements broken up into two main categories: annotation elements, which be text, dimensioning, symbols, tags, and so forth. And then for details, we have detail lines, filled regions, which is pretty much hatching, and 2D detail components, again, maybe just a combination of detail lines. All right. Now, type properties. So the same set of properties is common to all elements in a family, and each property has the same value for all instances of a particular family type. Right? This sounds confusing, but I'm going to explain that in a bit. So there's something called type properties, and there's something called instance properties. Now, let's look at the type properties again. The same set of type properties is common to all elements in a family, and each property has the same value for all instances of a particular family type. For example, All elements that belong to the desk family have a width property, but its value varies according to the family type. Thus, every instance of the 60 by 30-inch family type, and there's the metric value within the desk family, has a width value of whatever millimeters, while every instance of the other family type has a different width value. Now, let me explain that in the Revit environment. If we look at this bed, we can see that there, from the properties palette here and the type selector, that it's got three different types. It's one family, but it's got three different types. So we've got the 965 by 1880 millimeters twin, we've got the 1346 by 1880 millimeter double, and we've got the 1525 by 2007 millimeter queen. If I select on any other type, obviously that's going to change in the model. So we're selecting a different type. But if I copy this across, if I create another instance of the same family and type, it means that their properties are shared. So if I were to change anything in the type property, so if I go here to edit type, and I change the width here to something ridiculous to see what happens, you're going to see that both of those instances have changed because we have changed the type properties. Okay, so that's what we talk about when we talk about type properties. If we talk about instance properties, it means that only this instance will change, and those would be the properties that you see down here. Currently, for this particular family, it doesn't have any controlling properties as an instance property except for the level property. If I change this to level 1, that is going to change and move this bed to level 1. It's got an offset there and everything, but it'll only apply to this bed. If I look at the next instance, those properties haven't changed because it's not a type property, it's an instance property that I've adjusted. By the way, if I wanted to undo these changes, all I have to do is to press Ctrl Z until I'm back to where I originally was, just like any other software. So that covers type properties and instance properties. Next, we're going to look at the Revit native file format. So there's a couple that we want to look at here. The most important one here is RVT. So if we go and we say that we would like to open a Revit project, then typically what we would want to open is a Revit project, which is RVT for Revit, right? This is any project created in Revit. It's important to note that Revit versions are important and the file version that's saved in is important. You can upgrade older projects to a newer version, but you cannot downgrade a newer version to an older version of Revit. So this is very important, meaning that if I work in Revit 2024, which is what we're currently working on, I'm not able to save that back to a Revit 2023 or any other version lower than that. But I can open an older version of any previous Revit version in Revit 2024. It will upgrade it, and once I save that in the 2024 version, I won't be able to downgrade it again. Okay, so RVT files are the ones associated with Revit projects. You'll see another thing here called an RTE. That is a Revit template file, right? So we don't want to be opening templates. We want to be a project template. We want to be opening Revit projects. Okay. So the next one is if we go to new and we want to create a new project, you'll notice that now it's asking us select a template. So these templates are saved in a library location on your computer, and that is installed when you install the Revit components libraries, which I'll explain in the next module. But here you can see the extension is .rte. All right. So if I look at my New Zealand templates here, I've got 4 of them. There's a construction one, there's a default one, there's a LT one, and there's a structural analysis one. All right, so these are the template files for the RTE extension. When we look at formats for creating new families, so if we wanted to create a new family instance, you'll see that we've got an RFT extension there for Revit families. So those are the most important ones. RVT for Revit projects, RTE for Revit templates, and RFT for Revit family template. So if we want to create a new family, then we'll use the RFT template file. If we want to load a family, so let's go back here and let's click on component, and I want to load a family, then you'll notice they've got an RFA extension. Okay, so RFA is a family format type. Okay. Right, that covers that. And let's look at import and export formats and linking to models. Right, so in Revit, we're able to import drawings from AutoCAD, MicroStation, and other formats such as SketchUp. IFC is a special format that is an open industry format for building information modeling. So IFC is the equivalent of DXF files in the CAD environment. So DXF is an open source format that any CAD package can choose to use. It's not proprietary, and it provides an exchange. It's actually a drawing exchange format. That's what the DXF is short for. Now, in the BIM space, of course, the DXF format with lines and 2D CAD components doesn't cater for the 3D modeling environments. So we needed a new format to support these intelligent volumetric entities. And the IFC or Industry Foundation Classes format was born. And this is what's used as the interchange format between software packages such as Revit, ArchiCAD, Tekla Structures, and others. Okay. DGN is a MicroStation design file, so that's another CAD package by Bentley Systems. DWG, of course, from AutoCAD. SketchUp, SKP files comes from SketchUp, so you can import all of those into Revit, and then point clouds as well, which is RCP or RCS file extension. You can also export these formats from Revit. So from Revit, you can export views and sheets and even 3D views to DWG AutoCAD format or DXF. You can export to MicroStation files. You can export IFC, which we mentioned before. You can export this to Navisworks cache files or Navisworks document files, which is a software package used for construction sequencing and planning, and model coordination and federation. FBX, which is a popular format used in visualization, production, and gaming engines and such, 3ds Max and the like. And then there's GBXML, which is used for building analysis exports. So depending on the function that you're using in Revit, whether you are using the file menu and exporting to any of these various formats, you can export them there. Or if you're importing, you can either select the insert ribbon here and link to existing data, which means it's dynamically linked. So if I link to IFC or link to CAD, it means that whenever that CAD file changes, my model will update. Or if I import them, I create a static instance of those imports, and I can visualize that in my model. Okay, so that covers the information on this module, and I hope to see you in the next module. Bye.